Now we're going to look at energy flow diagrams. And to explain this, we're going to look at a particular situation, just one. And that situation is a ball which is held stationary above the ground. And the ball is about to be released, so it's about to fall. The question we need to ask ourselves, what energy transformations will occur? So we have a look at the ball which is held a certain height above the ground. So we know that it has gravitational potential energy. As that ball begins to fall, notice that the height above the ground is now less, which means it has less gravitational potential energy. We also know that that ball, when it's falling, it starts to move. In fact, as it keeps falling, it'll speed up, it will accelerate, which means it must be gaining kinetic energy. So we say here that some of that initial gravitational potential energy is now being transformed into kinetic energy. Just before hitting the ground, again, that height is nowhere near as much as it was at the beginning. So most of the gravitational potential energy has now left the ball, but it hasn't just left, it has now been transformed into kinetic energy. And the kinetic energy of the ball at this point will be more than it has at any other stage of that ball falling, until the ball hits the ground. Now, there is no height above the ground anymore, which means the ball has no gravitational potential energy. Where has it gone? It has been transformed totally into kinetic energy. Now, at this stage, we're assuming that the ball has just hit the ground. It hasn't been slowed down by the ground yet, because when that happens, there's a whole range of different energy transformations that are going to occur, but we're going to keep it simple for now. So we want to draw that as an energy flow diagram. So what we do is we start with a little box that has the initial type of energy in it, in this case, gravitational potential energy. And we know that that gravitational potential energy, through working through that situation, has been transformed into kinetic energy. And what you have there is a really, really simple energy flow diagram. But in reality, it's actually not that simple. So we go back to our gravitational potential energy converted or transformed into kinetic energy. But as I said before, when that ball hits the ground, there's some different energy transformations that are going to occur. One could be some of that kinetic energy is getting transformed into heat energy, which is going to increase the temperature of the surface of the ball, of the grass, of the air around it. Okay, some of that kinetic energy could also be converted into or transformed into sound energy. We hear a ball bounce most of the time, particularly if it's a basketball bouncing onto a hard surface. There's a whole range of things we could have in there. We could add in there kinetic energy being converted into elastic potential energy. And we could then go and say that elastic potential energy is converted back into kinetic energy, and then the ball will bounce back up and it's converted into gravitational potential. But just to keep it simple, we'll just leave it at that point where we've got our gravitational potential energy when the ball is at a certain height. As it falls, that gravitational potential energy is transformed into kinetic energy. When it hits the ground, some of that kinetic energy could be transformed into heat, some into sound, but we know that there could be more forms of energy that kinetic energy is transformed into as well.